So I will focus on the exercise. So we will probably look at all exercise and try to devise some answers. So the first thing is the Markov decision process, and let's see. Ruben, can you give me an idea? Can you explain what will be concrete example of MDP? What application? What can you explain MDP with an example?
Last week we were discussing some games.
Game, yeah. So which game?
We were discussing tic-tac-toe.
Yeah, tic-tac-toe. Then if we want to solve tic-tac-toe with the Markov decision process, what we need to do?
There are some actions and state. And
Then what will be the action and what will be the state?
states will be the grid with position of some cross
Yeah.
or zero.
Maybe we can build a one-half vector of dimension 9, okay?
Yeah.
So only one will be 1. And how will you represent state?
For like 0 and 1 for cross and O, like that in the grid.
So can you 0 and 1 for cross and O? So can you make a sentence?
So in the grid, okay, then we think there will be some empty. Then say like 1 for at some position, 1 for cross, and 2 for O marker, and other zeros are for that is empty spaces.
So 0, 1, 2. Okay, very good. Then let's think about what will be the problem that MDP will be challenging. Shade, can you give me an idea? What? Let's say this. What will be difficult to solve using the MDP?
The difficulty is I have to know the state transition reward.
Transition reward.
So that means I have to know the whole state transition rewards into our environment.
Actually, in Markov decision process, there is no mention of reward yet. Okay.
I think when the states are not finite.
State is not finite. That's very good. So it's not finite. So Aishwarya, can you think of concrete example? This is good, by the way.
Maybe something like Temple Run. I don't know.
Temple Run.
Yeah.
So there's no end goal. The goal is to keep running as far as you can.
That's the slightly different, but also it is not right answer.
Okay.
Okay.
It's basically when the next state is truly random. So,
Next state is truly random.
so you
I
can't
don't
predict.
think that is the still problem.
But the whole point of MDP is that with your current state, you can predict the next state. So if you can't predict the next state, then it's
Yeah, but if it is truly random, all the best thing you can do is just doing random thing, which solves the problem. Okay. You say, oh, but professor, the performance is not good, but that's the limit we can do. What rational agent or intelligence agent can do. The best thing rational or intelligence can do, not the God. Okay, so if the problem maximum theoretical achievable reward is random, if it is throwing dice, let's say it's 1/6, then achieving 1/6 is okay, acceptable for intelligent agent. So Aishwarya's point is right. So can anyone suggest concrete example of this case? Ruben, do you have any idea?
So exploring the
And by the way, if you, let's say you are doing temple run, okay? Who plays temple run? Who knows temple run? Okay, everybody knows. So what should be the state?
First thing is dead or alive.
Pardon me?
First thing is dead or alive.
But no.
Dead or alive?
If you die, the game is over, right? So that doesn't matter. If you die.
What? I didn't.
Dead or alive? That means
Where
someone
is
is
it?
died.
It alive or dead? Died already.
Oh yeah. So state is alive. Good.
He's alive.
Yeah.
And currently, any obstacle.
Any obstacle.
The level, I mean, in temple run, after a few more, the
In-
speed increases. So it could
And
be some
current
level
jump
or
rate.
time.
Also, I think there's someone chasing you, so the distance behind.
Someone chasing
Chasing
you.
you, yeah.
Someone
The distance.
is chased. Okay. And is there any directional key in the Templar? No,
Yeah.
right? Is
Left,
there any
right.
Yeah,
direction?
there are
Left, right.
turns. So
Turns,
there's
okay.
left turn, right turn, and
Left,
jump.
right,
Jump and
slide.
slide.
Jump is for obstacle.
Obstacle.
There is slide. I didn't know that.
Yeah.
Okay, let's say there is a direction. Okay. But for direction is action, and maybe it will be each road direction.
Yeah, road. Yeah.
So, and any obstacle in jump lanes means that when you at time step t, if you have to make a jump, then the in the game screen the obstacle will be probably somewhere around here, right?
So we also need to know the speed, because as you keep playing, the speed gets faster. The speed increases.
So speed.
That's said some levels maybe.
Yeah.
Some levels. I mean, after a few time of running, the speed increases.
But
So you
speed
can
is incorporated. What additional information level
The speed.
gives you?
Also, when he gets into that container sort of, the trolley sort of thing on the tracks. right?
Okay, so
Okay,
depends
okay.
on which version. We
I
are talking
think-
about the simplest.
I think we are getting unnecessarily too detailed.
Yeah.
My question is this state is finite or not finite?
It's not. Sorry. It is finite.
Maybe it's finite.
Finite. Who thinks it's not finite? Everybody thinks this is finite.
No, it's supposed to be infinite. Yeah.
Yeah.
It's infinite. I think.
Who is against this being finite?
So I'm just thinking out loud. I don't know if it's finite or not. So, despite wherever that agent is in the game, the values of these factors are changing, but the factors themselves are not changing much.
No, if you think about the speed, the infinite speed. So as long as you can survive, the speed keeps increasing at a constant rate. So there are the states are infinite essentially because
No,
there's
speed
no
is value. I think just that is another change of the value. So which is already recorded in speed variable.
No, I'm telling. See, he's alive, he's dead has like finite number of values. Like all other parameters have finite number of values except for the speed and the
I
level.
think by infinite, I think number of state is infinite.
Yeah. So that was the question.
Pardon me? So who can you summarize your discussion?
Okay. No, he was saying that except the is alive part, for all other
No.
like speed will be increasing. So he was saying that speed is infinite. But
Speed is infinite.
Since
Yeah,
there are
but I
infinite
think-
possibilities for
Infinite possibilities.
for speed, there are
Mhm.
infinite. So you can have unique frame for each speed
Mhm.
with all the other values. So the
Mhm.
number of frames is infinite essentially.
So who agrees with the Sanas? Who disagrees with the Sanas?
I think the speed is only another just value,
Mm-hmm.
which can be anything. but-
Value, but
Yeah,
is it continuous or discrete?
If let's say if you are building temple game,
Mhm.
okay, you will say okay the speed is 5. Next time it will be 7. Next time it will be 9.
Mhm.
Next time it will be 10. Okay. Can we think of a speed of 1 million?
There
Or
is a
speed
range.
of 5.002345677 and then speed of 5. Do we need to think in this way?
No.
No, right? In real world, if you are actually doing temporal run as a human, this might be a continuous variable, but probably this implementation is not continuous. And even though, let's say, there is a we randomly sample from the speed of 0 to 10, as a programmer, you say, okay, I will generate infinite number of state and say, create an infinite number of possibilities for the speed, let's say. Then we can still model or approximate the real world
Mhm.
into the model and get reasonable performance, right? This speed change does not matter.
Okay.
Okay, so we can just map them into some other
Bucket.
bucket. So even though in real life something is continuous, which means the state is infinite, in many cases, if we approximate them, then it works reasonably well. That's why Markov property is very popular in computer science, even though in real life nothing is Markov. But still, it works reasonably well. So in the case of temple run, I would say this is a relatively small state size, state space. What will be can you guys think of other examples
Where the state size is larger.
where using Markov decision process to model does not produce reasonable performance?
Like in an open world game,
Open world game,
like GTA 5.
GTA 5.
Maybe just Markov model wouldn't work because there are too many non-player factors that need to be taken.
GTA 5, is this online version or?
Online.
Yeah. It has a story also, and is also.
No, but story is more controlled, right? You can have finite states in story,
Yeah.
but when you go online, it's more chaotic.
Yeah.
Like you can't control what other players do, right?
Yeah. So I think this is a good example. This is also, even though this is a discrete digital game, this is a very good simulation of real world, right? So
Actually, even Skyrim, I don't know, Elder Scrolls 5, Skyrim.
It's offline.
No, it's offline, but the game has so many.
It's
So-
just really big.
Yeah, it's really big in the sense that I'm not sure anyone has ever finished the entire game. No, there are too many. So it's been
I think
around
guys-
for more than 10 years and
Mhm.
no one
Yeah.
has finished the
So once I think we have a reasonable understanding of what is the Markov property and what will be the limitation of it. So everyone, let's solve exercise 3.3. So there are different levels of the modeling, same problem. So we are basically have a real world which is intractable and build a model of which will give you reasonable performance with tractable number of state. What is the tractable number of state? Because
Finite state.
yeah, everything is finite state. We can say everything is finite state. We can say even these floating numbers, if we use computer to represent it, then this is the finite. Okay, even floating numbers are finite, but we can say is this number tractable, meaning we can solve. So let's say we use 64 byte to represent float. Then how many states are there for each continuous number? Can anybody say?
How many states for each number?
Yes.
Two floats.
Two. I'll make it simpler. Let's say I use 8 byte.
2 by 8, how many?
8 by 4.
76. 2
How many states are there?
Infinite floating number can take.
That's the point of the question I am asking you. So, is it this 8 byte floating number has an infinite number of possible state?
No, finite.
Finite.
Yeah. So, what is the number of state?
2, 4,
256.
82.
So,
No, because it floats you have the
Yeah,
value raised to
yeah.
So you guys are making problem more complex than the necessary.
Should be 2 power the number of bits.
Yeah. It should be 2 to the power of 8 by 8. Okay? Does
that
this
many
make
spaces or that it can be either 0 or 1.
So this is a 8 byte of binary numbers. One can be 0 or 1. And we have a 64 bit. Right? So it's a 2 to the 64. It's a very large number. One would say it's very easy to say I'm not sure, but people usually say there is more. This is more than the
number of stars.
number of atoms in the universe.
Oh, okay. Number
Yeah.
of atoms.
Yeah. So that's how they represent when something is finite but not tractable. Okay. So let's say Rubel, can you give me your opinion about exercise 3.3? Okay, guys. It feels like a cheating because I'm not teaching and I'm just asking questions. But for next week's seminar, everyone should bring their answer sheet for the whole exercise. Okay, to reduce the time. So the one who reads the paper seminar should be able to provide relatively correct answer. Maybe there can be an error, but so the role of the seminar will be the discussion of the individual answers. Do I make sense?
Yeah.
Okay. So Aishwarya, do you have any idea?
I think like when he says you can go in higher levels and define the actions as how the agent thinks and all that.
Oh.
No.
Mhm.
That's not my answer.
Yeah.
So that I think is too abstract, but I think a good level would be where the agent is actually taking the interacting with the things, so that when the game is going on, the actions are consistent. I mean,
Aishwarya, so you didn't get the question yet. So this is a multiple choice question. Okay. Choice number 1 is you model state as actions as a accelerator, steering wheel, brake. Option number 2. What is the option number 2?
Where the rubber meets the road.
Well, so
Basically,
Action to be tire torques.
Tire torque, yeah.
so how will you write a tire torques?
Acceleration of the
What's the
motor.
parameter of torque?
Yeah, actions.
Rotation,
Yeah.
There's some
So this
rotation.
will be basically binary numbers. So 0 or 1, excel or not, brake or not, steering, let's say right, neutral, left. So we can say, oh, Professor, I want 0.5 excel. You can do that, but this is more simpler. So it's another way of representing action, but let's make it simpler. So this is all discrete multiple choice, and if we represent where tire meets the road, how you should write the actions. It requires a little bit of the physics knowledge. So can anybody try? It don't have to be right.
The angular momentum into the radius of the tire.
Angular momentum. So how will you write?
be a continuous value.
Yeah, so it will be continuous value. That's correct. And how will you? What will be the, for example, dimension of the action space? This is the vector of
So
continuous
you need
number.
four at each tire one.
So who thinks we need 4 numbers?
Actually, two we can do.
2 numbers. Okay.
No, actually. But
So
the problem
Sanas, stop.
Yeah.
Shadek,
Differential, right.
how many numbers?
I'm not sure, I forgot physics.
Ruben?
The second state.
Each tire can have different.
Yeah, actually. That's why I told 4 because differential.
So 4, 2, so Ruben 4. Aishwarya?
The average, I think, 1.
Average 1, yeah, so 1. Who has a different opinion?
Much more.
Much more so.
It's not just the tire torque, you also have to this about, say, how much pressure to apply to the brakes, how much...
No, if you apply brake, then torque reduces.
Right, but it's a different input, right?
No,
the
it's
negative
the
of
same input, yeah. If you...
The torque goes in the opposite direction.
Yeah. So Any different opinion?
I think 3.
3. So
Because usually there's a differential drive, so the back 2 wheels will be at a different.
that's
Speed?
unnecessary too much, but I think that is good. So I think it's probably, if I do this, I will say probably 4 to 3, which will be like 12. Okay. For tire torques for torques value for each tire is a 3-dimensional value, not 1-dimensional value, because
Okay.
there is a directional
Yeah.
information. Okay, do I make sense?
Yeah. Okay.
So it's a 12 continuous vector. What is the third option?
I just have a question.
Mhm.
So, if you define the action that way, I have to press the brake so that I achieve that particular value, or
Yeah, if you, let's say very simply, if you press the value, then the tire torque will reduce from 10 to 1, for example. Okay? So, and what is the third option?
It's like location.
Muscle. Third one is
Muscle twitches.
controlling your muscle. I mean,
Yeah.
Oh, okay. Then there are 4.
So, in third option, what will be the action space, dimension or format?
You need
I think
one indicator whether to apply pressure on a brake, accelerator, or clutch.
No, it's hand
I think
muscles.
It will be a lot.
Yeah, handle leg, but you're driving the
Because
muscle.
they're
Car,
talking
right?
about the muscle twitches and not the movement itself.
So, can anybody say the number of dimensions and the values?
I think just one hand has about
Mhm.
some 100 or something.
So
a
hand-
big number of muscles.
100 muscles for the
For
Just-
the
hand and each foot, so
Yeah.
it will be 400.
yeah.
400 muscle to each. Okay, and because this is muscle, it's difficult to say, but I think we can model it as a binary. Okay, 400 binary number. Yeah, it's a muscle twitch. If you think of muscle
contract
fiber,
and relax.
yeah, contract or relax. There's a 2 state, but this is 2 to the 400, 2 to the power of 400.
400.
Yeah, so. And fourth option,
Is that where you have to
where
go?
to drive decision.
how can we represent it?
Like some global coordinate system, like location, longitude, latitude.
Longitude, latitude. So it's actually 2 continuous number. Okay. Let's start. Which one is the? Actually, you need a starting point.
Oh, start.
So 4 continuous. So actually, I already gave you the answer for the second question. The way we select the action
Should be
is considering reasonable performance with a tractable number of states. Okay. So if we think about this, what will be the best action representation?
First one.
Yeah, first one. Then if we think first one, what will be the second best representation?
fourth.
Fourth one. Fourth one.
Second one.
So who thinks fourth one? Sana, Sanjay. Oh, they are all Sanjay and Rubel. Who thinks second is the
I
better?
think the fourth one.
Aishwarya. And second one, Paul.
I actually think it's the third one. Sorry.
Oh, okay. Okay, third one, Aishwarya. So Shadek,
Yes, second one.
second one. Okay, now
Actually, second one. Yeah.
okay, actually second one, Sanas.
More reasonable performance.
And
That is more practical.
Sanjay, can you give me idea why you selected fourth one will be better? Pardon me?
I think I'll go with two. Yeah.
Oh, you go with the two. Okay. Ruben, you are the only one.
I should move to 2 again.
Okay. Why you, Ruben? Why you think second is the better one?
Since starting and destination, all these will be, all other variables will be controlled based on the
So, Ruben, you have a bad habit of not completing sentence. Okay, you should always, even if you are wrong, it's okay, but you should deliver what you think correctly, completely.
For with the start and end coordinates, I can control all other things to achieve that. I mean, all the
Oh, I didn't get the idea. Can you say again?
with fourth one,
So you still think the first one is better?
I'm confused actually.
Okay.
I'm not sure. For fourth one, I thought earlier that with source and destination coordinates, all the necessary variables will be controlled with that intention.
Yeah, or every representation works well, right? Every information, every action can achieve almost approximately same thing. So there is no problem with the performance. There is only problem with the number of action state. Aishwarya? You are third. Why you think so?
I thought because it's a binary value, it should be easy, but then that is greater than the 2 power 64 representation.
Yeah,
So,
yeah.
No, it's not because
You are cancelling this. Yeah, smart. Then what's your vote? Everyone knows third option is the worst. Okay. Then we are considering option 2 and option 3.
Option 4.
Option 2 and option 4. And if I apply same rule, hey professor, there is only 4 continuous number compared to 12 continuous number. This should be smaller number of continuous state, right? But almost everyone thinks second is better. My question is, why second one is better?
It gives more reasonable performance.
Performance-wise, it's the same.
Same?
Yeah.
Okay.
I mean,
Because
second
if
one.
you think about it, the fourth one has only the start and the end. But here you can actually get for the path, each states in between in the path also. Over there, at any state, wherever you are in between the source and the destination, you only have the information about the source and the destination.
I think in terms of the performance, it's the same.
Okay. If they are the same, then the fourth one would be better.
Okay. Anyone? Paul?
My reason behind it is, although those are 12 continuous vectors, you could approximate it to say a reduced number of states.
Very good. It's actually very good. So when we are dealing with a continuous number, we are not actually doing continuous number. We do discretization, bucketing, right? and we reduce to the discrete state. And if we have, let's say, 12, even though we have a 12 continuous vector, we can easily represent each vector from 0.1 to 10 point. So have a 10 representation, 10 discrete representation. And then still we can achieve relatively good performance. But if we think about the lateral, what is the lateral and longitudinal distance? How many grid will give you reasonable performance for driving?
I mean, it's a very long range. I mean, the whole world, basically the coordinate of whole world. That means even if you discretize, it will be a huge space, huge stage.
Yeah, so that's why second is the better one. Okay. Okay, now go to recycling robot. So my default assumption is you guys already read the book, so I'll skip the explanation of the exercise 3.3, example 3.3, and go to the exercise 3.4. Ruben, we are building table, right? In exercise 3.4.
Yeah.
Oh, you don't have the book. Okay.
I'm watching.
Yeah, you are using your phone. Okay. Next time bring notebook or anything. Okay. So how many rows are there in this table?
Rows will be.
Mm-hmm.
I have to go to the international. This website.
Okay.
Into CHP into and error for every
Shadek, how many rows will be there?
How many states?
How we are solving exercise 3.4.
Yeah.
Okay, and exercise 3.4 is building a table. And my question is, how many rows will be there in this table? Aishwarya?
How many what?
Row.
So it says row for every 4 tuple for which
Paul?
S is 2 into 3.
Pardon me?
Go above.
page 53, 18 or 50. Because before, just
like say the condition SA for S there are two actions, high low, and for A search wait research, so 3, so 2 times 3 should be on the condition side, and for probability of S prime R, for S prime still 2 low high, and for R search I don't know how many different result for R.
This is class 1 for picking objects and negative for steps. Small negative for
There is value of -3 0 wait search, I don't know, so in total so, 8
1, 2 rows.
7 rows.
7.
Eliminating the ones with 0.
Okay, then let's do easier question. Okay, so what is the we are getting
P of
building a table
S was
S prime R given S A. So let's do one thing.
for every 4 non-zero.
So high reward is reward search given let's say this time low, and action is search. What is this probability?
Unit by alpha.
Low search. Low search high is 1 minus beta. Low search high. Oh, current is high. Current is low. Search high is 1 minus beta. It's low to high, right? S is low. S prime is high. And action is search.
So
No, it should be 0, right?
So we have two opinion. 4 minus beta and 0.
See low to high. See the diagram. Low to high.
Any other opinion?
No, the action is search. It cannot, when your battery is low, you cannot search.
You cannot search because you need to research.
reward is -3.
So everyone prepare to vote for answers.
-3. So P of that is 1 minus beta. The reward is -3. See this, when it's going from low to high, 1 minus beta and
Okay,
-3.
but this is your action, right?
Yeah.
So when your current battery is low, if you search, okay, there is 0 probability of going to high. Your S prime is high.
Yeah. This represents S and this represents S prime. The other way around. So when S low, action search, S prime high. So when you align with
It's 0.
1 minus beta, reward is -3. Low search high, 1 minus.
Yeah, but even then, your reward cannot be R search.
Because the battery is low.
Yes. So your reward would be different. So that probability is 0. The probability that you'll get R search is 0.
So now let's do both. Who thinks it's a 1 minus beta? Sanas and Ruben. Who thinks it's a 0? Shadek, Paul, Aishwarya? Aishwarya? Okay, it's a 0.
It's
Okay,
recharge.
so Ruben ask Shadek or Paul about why it is a 0. Okay,
You were saying that, later, okay.
pardon me?
No, I mean you ask them later on, later time.
Maybe you can do it right now. Yeah. Or can anyone explain why this is
So
0?
basically, if your current state is low and you take an action to search, okay, you can never get the reward as search. If you see, that's not in the table,
Yeah.
right?
Yes.
With the next state being beta. Okay, so you'll always get a reward of -3 to take that action because your battery will get depleted. And that's why the probability is 0.
Okay. Ruben, does this make sense?
Yeah.
Okay. Paul, can you suggest one law where the probability is larger than 0?
Larger.
Yeah.
Say the first row, which is your current state is high,
Current state is high.
your action is search,
Search.
the
Sorry, action is search.
Action search.
Oh, I'm sorry.
And
Yeah.
next state is also high.
S prime is also high.
I think this is easier, so easier to
Yeah.
get. So when you are high, you search it,
Then-
and still you are
High.
high.
And the probability of
Oh no.
Okay.
You are not there yet.
Yes.
What will be the reward?
Reward is
R search.
R search. So what happened is, you have a full battery. You search it, and you actually found something, and the battery was still full. Okay.
Yeah.
What is this probability?
Alpha.
Okay. Does this make sense, Ruben?
Yeah.
Okay. Then. Ruben, can you make one more row? One more items? One more rows?
Your current state is low,
Current is low.
and then action is recharge.
Recharge.
Then go to high.
You become high.
There is no reward actually. for it.
And no reward.
Probability is
1.
1.
1.
Probability is 1. Okay.
Wait, low recharge.
Aishwarya, can you write one law? Let's try Sanas. Sanas, can you give me one law?
Yeah. So when the current state is low
Current is low.
and you wait,
You wait.
the current state is low again,
Low.
then the reward is R wait
R wait.
and probability is 1.
Probability is 1. Shade?
State is high,
State is high.
action wait,
Wait.
next state high,
Next state high.
reward wait,
Reward is
R wait,
R wait.
and probability 1.
Okay, 1. Aishwarya?
I was thinking of that one.
Yeah, but
I will try.
if you know how to do it, it's actually very easy. So.
I'll just try.
Okay, Aishwarya, you should build this table, okay?
Okay.
And let's go to other exercise. So now we go to the concept of the reward. We talk about reward just now, and there is a simply speaking, reward will be we define G as a expected return, which is simply speaking is all expected reward from now on. Just a sum of all reward. So this is when the each episode is finite, the sequence is finite, but mathematically, when there are infinite game like a life, even though humans die, so let's say there is a continuous process like a thermostat, okay? Then we can still write a GT, but introduce gamma. So gamma is we call discount factor. Okay, so the main idea behind Bellman equation is, if we look at this formula, we can represent it with t plus 2. It's a gamma, not R, but this is again GT plus 1. So mathematically, simply you can say the expected return is current reward plus discounted factor multiplied by the next return, next expected return. So the equation 3.8 multiplied version of 3.3. Okay, the time is up, so we will continue next